Alright, in this video we will explore the relationship between a function, and here written in factored form, and the graph of that function. And there are a few facts that you really need to memorize. And here are some of them. The graph will behave in different ways depending on the multiplicity of a particular factor or a particular zero. So if a factor is just a single factor, then at that particular root, the graph just passes straight through like this. On the other hand, if the factor is a double factor, multiplicity 2, then what the graph does is it bounces off that particular zero instead of passing through. Now, if it is a triple factor, which means this would be a triple root, multiplicity 3, we have what's called an inflection, where the graph sort of flattens out as it passes through and then continues on through. So, single, straight through, double is a bounce, triple is an inflection. So as I glance at this first problem, I see a couple of things. First of all, I see that we have x-intercepts at -1 and 3. Okay? The x-intercept at -1 means that we're going to have a factor of x plus 1. Now, the fact that that's a bounce means that this must be a multiplicity 2. Now, the 0 at 3 means we're going to have a factor of x minus 3. And the fact that it goes straight through tells me that it's just going to be plain, a single factor, multiplicity 1. Now, I need to worry about whether or not I need a negative sign in front of this function, because sometimes you do. Okay, to answer that, I need to look at one more piece of information. Will the leading coefficient be positive or negative? I can tell because at a glance I will know whether or not this function is even degree or odd degree. If both arms point in the same direction, I'll know that's even degree. If I have one arm up and one arm down, then I know that's odd degree. So let's look back and see. I have one arm up and one arm down, so right away I know this is an odd degree function. Alright, so now that I know it's odd degree, now I can look and think about whether it is a positive leading coefficient like this or a negative leading coefficient like this. And there's a couple ways to look at it. I think about the letter N, capital letter N. If it has the N behavior like a capital letter N, I have memorized that that is the positive version. And if it's like a backwards N, that's the negative version. Okay, so looking back at this problem, this is like a backwards N, so I know this is the negative version. So I'm going to need the negative sign in front. Another way to look at it is if the right-hand side is down, it's negative. So in other words, these two are both the positive cases, and notice that the right arm is up. These are the negative cases. Both of these are the negative cases. And in both cases, the right arm is down. So if the right arm is up, it's positive. If the right arm is down, it's negative. And here I see that the right arm is down. So that also is another way of knowing that I needed the negative sign. Alright, for number 5, we are going to use the same information, but we're going to go in the opposite direction. We're going to go from a factored form equation to a graph. So first of all, if I have a factor of x plus 4, I know I'm going to have a 0 here at -4. And if I have a factor of x minus 6, I know I'm going to have a 0 at positive 6, an x-intercept at positive 6. Now, let's talk about bounces and inflections and whether or not the graph just goes straight through. Well, because this is that multiplicity 3, we learned that when you have a triple, it's going to be an inflection like this. All right, so we know that we're going to have an inflection from this. Now, please understand that that means, so we're going to have an inflection at the -4. And we have learned that when it's a double factor or double root, that's when you're going to get a bounce. So we should have a bounce at 6. Well, yeah. All right, so we're going to have an inflection at this -4 and a bounce at 6. Keep that in mind. But before we can draw the graph, we have to know which one of these types of end behavior we're going to have. Is it going to be like this, or like this, or like this, or like this? Now, I know that these are the end behaviors that you have when you're talking about even degree functions. And these are the end behaviors that you have when you're talking about odd degree functions. And these are the positive versions, and these are the negative versions. All right, so I need to know the degree. Well, there are 3 of these and 2 of these. That means we're talking about degree 5. Okay, that means we're talking about odd degree. Because we have this negative here in the front, we know that we need to have the end behavior in the negative version. So this is the end behavior that we are picturing as we go to draw our graph. Specifically, as we go to draw our graph, we need to make sure that that we start off way up high as we draw the graph. So I'm going to start off up high because of that analysis, and I will do an inflection at -4 and a bounce at positive 6. So here I go. Starting off up high, this is what an inflection is going to look like. All right, so there's my inflection so far. See how I sort of flattened out and then it disappeared, so that's awesome. Let's try that again. All right, now I need to swing around in time to do a bounce off of the other one. Okay, notice how it does have the end behavior that we spoke of, how it's high on the left and low on the right. Notice I did not cross the x-axis at any other point other than my 2 x-intercepts. And that's how it's done.